Hi students, I hope you are doing well. Today we are back with one more video related to the real numbers. Topic is real numbers, and from that we are going to discuss decimal expansions of real numbers. So as we discussed in the last class, this kind of sums the same type we discussed. How do we get the decimal expansions of real numbers, and also in that we just checked whether the given decimal is terminating or non-terminating decimal, okay, by just using the theorem which we discussed yesterday or like last class especially. So you're able to write the denominator in terms of 2 power n into 5 power m, especially the denominator if you're able to write in the form of 2 power n into 5 power m, like you can easily say that the given decimal is terminating decimal. And if you are not able to write that in terms of 2 power n into 5 power m, then we discussed or we concluded that as a non-terminating decimal. Okay, fine. Yeah. Now let me discuss some more sums related to that. The first one is 13 divided by 3125. First, you find the prime factors of 3125. So, what are the prime factors of 3125? If you divide 3125 with 5, 5 6 are 30, correct? 6 0, and you take 5, 25 will be there, 5 5 is 25. Again with 5, 5 ones are 5, 5 twos are 10, 5 ones are 5. Okay. I think, yeah, 5 6 are 30. 1 second. Let me do it 1 second. 5 6 are 30, correct? So we'll be left with 2, right? 12. So 5 2s are 10, 5 5s are 25. So next 5 ones are, 5 2s are, correct? 5 ones are 5, 12 will be remaining, 5 2s are 10, 5 5s are 25. So 5, how many times? 5 2s are 5 5s are again 5, 5 into 5. See, here we are getting only 5. So can I write this 3125 as 5 into 5 into 5 into 5 times it is multiplied. You just check the numbers of 5 are 5 times. This can be written as 5 power 5, correct? Okay, what I am doing, see, whenever you like they ask this kind of decimal expansions or sums, what we have to do, we have to consider only the denominator. You don't want to do anything with numerator, don't even take numerator, correct? We have to consider denominator, we have to take denominator 3125. So 3125, write the prime factorization of 3125. I just did the prime factorization over there. 5 6 5 2, and I hope you know that division part. So we divided and we got prime factor 5 6 are 30, and we will be remaining with 12. So 5 2 are 10, remaining will be 25. So 5 5 are 25. Next 5 1s are 5, remaining is 12. So 5 2 are 10, and 25 will be remaining. 5 5 are 10, like 25. Next 5 2s are 10, and remaining is 5. 5 5 are 25. So 5 5 are again 25. So you will get 5 times 5. It is same as 5 power 5. So my question is it in the form of 2 power n into 5 power n? Correct? Is this 5 power 5, which is 3125, which you have written, is that is in the form of 2 power n into 5 power m? Yes, you can write in that form. Okay? I can write this as 5 power 5 into 2 power 0. Can I write this as 5 power 5 into 2 power 0? As I told, any number, okay, power 0, anything power 0, we know this formula, it is very, very useful and very basic formula. X power 0 is equal to 1. X may be anything, a power 0, 2 power 0, 3 power 0, any number, any term power 0 is 1. So similarly, 2 power 0 also 1. So 5 power 5 can be written as 5 power 5 into 1, and this 1 can be 2 power 0, but we need to express in terms of 5 power m into 2 power n. That's the reason I am writing it as 5 power 5 into 2 power 0. It is not wrong because 1 can be written as anything power 0. So we need it in the form of 2 power n, that's why 2 power 0. I can write 5 power 5 as 5 power 5 into 2 power 0. And here you observe it is in terms of 2 and 5. Correct? It is in terms of 2 power n into 5 power m. Correct? So if the denominator can be expressed in the form of 2 power n into 5 power m, then what kind of decimal it is? I can write here as, I'll just write here. Okay. This can also be written as 5 power 5 into 2 power 0. Correct? 5 power 5 into 2. So this is what kind of decimal? This is terminating decimal. Correct? If you are able to write the denominator in the form of 5 power n into 5 power m into 2 power n, then we can say that that decimal is terminating decimal. Okay, I'll just repeat once again. We have taken 13, the sum is 13 divided by 3125. So 3125 is the denominator, right? If you consider this as P and this will be Q. So Q is the denominator here. As I told you, we are not going to do anything with the numerator. Don't even look at the numerator. We don't want numerator here. We just take the denominator. Denominator is what? 3125. 3125 you can divide like that. Okay. So if you divide, you will get 5 times of 5. It means 5 into 5 into 5 like that. If you multiply 5 times, you will get 3125. That is how many times it is multiplied? 5 times. So can I write it as 5 power 5? So 5 power 5. And can I write, see, nothing is there, right? Okay, 5 power 5. And we don't have 2 in that. Actually, it should be expressed in the form of 2 power m. Correct? So we don't have 2. Can I write it as 2 power 0? Because we know that any term power 0 is 1. So 2 power 0 is also 1. So I am writing 5 power 5 into 2 power 0. Correct? I am writing in that form. So 2 power 0 is nothing but 1. So we are able to express this 3125 as 5 power 5 into 2 power 0. Okay? So if you are able to express in that form, this can be considered as terminating decimal, and we are not doing any division over here. Correct? By just expressing the denominator in terms of 2 and 5, we are checking whether it can be expressed in the terms of 2 and 5. Yes, we can able to express, so that is why it is called as, it is a terminating decimal. You divide and check, definitely you will get a terminated decimal. It means you will get a perfect answer. Correct? You will not get any recurring or you will not get any repeating decimals. Now, similarly, we will consider the second sum, which is 15 divided by 1600. Okay? So this sum can be written as 2 power 6 into 5 square. Anyway, I already did the division. You have to divide and check. Okay? 1600 can be written as 2. Just divide with 2. Because 1600 is divisible by 2. Correct? So, it is 2 8s are. Correct? Again, 2 4s are 400. Again, 2 200. Again, you will get 2 100. Next 250. Next 225. And 25 is not divisible by 2. Correct? 25 is not divisible by 2. So we have to take 5. 5 5s are 25. And 5 is a prime number. You cannot divide further. So 1600 can be written as 2 power 6. How many are there? 1, 2, 3, 4, 5, 6. Correct? So 2 power 6 into how many 5s are there? 5. 2 5s are there. 5 into 5, which is 5 square. So you are able to write 1600 as 2 power 6 and into 5 square. It means you are able to write in the form of 2 power n into 5 power m. Correct? So that is the reason we can say this is also a terminating decimal. This is terminating decimal. Correct? Because how can you say that it is terminating decimal? Because 1600 can be written as 2 power 6 into 5 square. I'll just repeat once again. What is the decimal fraction form given? 15 divided by 1600. 1600 you divide. Okay, you write in the 1600 in terms of prime factors. So when you divide, what happens? 2, just we divided with 2, we got 2 800. Again we divided 800 with 2, we got 400. Again 400 we divided, we got 200. Again 200 we got divided, we got 100. Again 250. 225s are 5 5s are. So because 25 is not divisible by 2, again we divided with 5 itself. Correct? 25 is divisible only with 5. So we divided with 5. So we got 1600 can be expressed as 2 power 6 into 5 square, which is in the form of 2 power n into 5 power m. So any number, especially the denominator, if denominator can be expressed in the form of 2 power n into 5 power m, then you can easily say that that is a terminating decimal. In this case, we have to write 2 power 0 because we have only 5. Remember, even if you get the decimal in the decimal expansion of the denominator, if you are able to get just 5 alone or 2 alone, that is also terminating decimal. Remember, for example, you are getting only 2 cube. Whether it is terminating decimal or not, yes, it is terminating because 2 cube can be written as 2 power 3 into 5 power 0. Okay. For example, you are getting only 5 power 3. So it means 2 is not there. So write it as 2 power 0. In the first decimal expansion, you don't have 5. In the second decimal expansion, you do not have 2. In both the cases, what I did, here 5 is not there, so that can be written as 5 power 0. As we know, anything power 0 is 1. So 2 power 3 into 1 is 2 power 3 only. We are not changing the value over there. We are just multiplying with 1. Instead of multiplying with 1, I am multiplying with 5 power 0. Both are same. So, because anything power 0 is 1. So, we express this in the form of 2 power n into 5 power n. So, we are able to express then definitely it is terminating. In this case also, 5 power 3 is there, but 2 is not there. So, can I write 2 as 2 power 0? Yes. So, similarly, I written 5 power 3 into 2 power 0. We are able to express in this form. So, that is also terminating. Remember, even though if you get the prime factorization of q as only in terms of 2 or only in terms of 5, even they are also considered as terminating decimals. Don't think every, like as they told in the theorem, you have to get 2 and 5. Sometimes you may get 2 alone, sometimes you may get 5 alone, sometimes you will get 2 also. In this case, you see, both you got 2 and 5. In this case, you see, you got only 5. In the last, decimal expansion, in the last video we got only 2 power 3. We don't have 5 power, 5 over there. So we written 5 power 0. So if you get 2 alone as a prime factor, if you get 5 alone as a prime factor, or both prime factors you get in the expansion of q are also considered as terminating decimal expansions only. When it is not considered, if you get other than this 2, means you have one more prime factor apart from 2 and 5. If 2 is alone is there, it is terminating decimal. If 5 alone is there in the prime factorization of q, yes, it is terminating decimal. And 2 and 5 both are there, yes, it is a terminating decimal. If 2, 5 and one more is there apart from 2 and 5, then it is non-terminating. That I will discuss. So I hope you understood. What I did, 1600 I divided and I got 1600 as 2 power 6 into 5 square. Definitely we are having 2 and 5. We are able to write in the form of 2 power into 5 power n. So that's the reason it is a terminating decimal. It's very simple. That's all. Okay, next. Let me go with the next sum. What is that? 6 divided by 15. Correct. 6 divided by 15 is a terminating decimal expansion or not? Let me do the prime factorization of 15 first. So what are the prime factors of 15? 5 1s are 5 3s are. That's all. Can we write further? 3 is a prime number. Can we divide further? No, we cannot divide. So 15 can be written as 5 into 3. Correct? 15 can be written as 5 into 3. It means 5 power 1 into 3 power 1. Okay? What we have to convert q should be 5 power n or 5 power n into 2 power m. Correct? It should be in terms of 2 power m into 5 power m. But is it here like that? No, right? So here we have, we are not able to convert in this q, which is the denominator, in terms of 2 and 5. We have 5, but we are not having 2. So definitely it has other prime factors apart from 2 and 5. So this is what kind of expansion? Non-terminating expansion. This is non-terminating decimal. Expansion or decimal we have to write. So it is a non-terminating decimal. Why it is non-terminating? Because in the prime factors of q, we do not have 2 and 5. Correct? 2 is also not there, but 5 is there. Remember, 5 is there. But in addition to that, we have 3 also. As I said, you should have 2 alone, or you should have 5 alone, or you have both 2 and 5 also 5. But you should not have, any other prime factor apart from 2 and 5. But we have 3 here. Definitely, it is a non-terminating decimal. Okay, see, it's very simple. I will just explain this once again. 15 is the denominator, we are taking 15 and we are writing the prime factors of 15. What are the prime factors we are getting? 15 can be expressed as 5 into 3. But here, you are not able to express that in the form of 2 power n into 5 power m. Correct? The theorem what it states. So we have, apart from 2 and 5, we have one more prime factor 3. That's the reason it is a non-terminating decimal. Okay? So this is done. Next, we will go with the next one, which is 35 divided by 50. Okay? Let me do the prime factorization of 50. So 2, 2 2s are, 2 5s are. Correct? 25. Next, we take 5, 5 5. So 50 can be written as 2 into 5 square. Correct? 50. Denominator 50 can be written as 2 into 5 square. So can we able to write this in the form of like 2 and 5, 2 power m into 5 power n. Correct? So we are able to write 50 in terms of 2 power m into 5 power n. So hence, okay, we can write working also for this. I'm not writing working for all the sums. I'm just writing for one sum. The same you have to follow for all. Okay. Here, the prime factorization. Okay. Let me remove this order. Of 50 can be expressed in the form of 2 power m into 5 power n. Hence, 30 by 50 is a terminating decimal. You have to write this much. Okay. Is a terminating decimal. Okay. Understood? This process is very easy. What we have to write? First, you have to consider the denominator and write the prime factors of the denominator. That denominator can be written as 2 into 5 square. Correct? So, in this 2 into 5 square, here you can easily tell that prime factorization of 50 can be expressed in the form of 2 power m into 5 power n as we studied in the theorem. So, hence 35 by 50 is a terminating decimal. In these 4 sums, we got 1 as a non-terminating decimal because that 1 is, what is it, 5 into 3, because you are getting one more prime factor 3 apart from 2 and 5. So that is, it is a non-terminating decimal. That's all. Okay. What you have to understand as a whole, remember I am explaining once again. First, whenever this kind of sum comes, you have to check the denominator. Denominator, for the first, you have to find the prime factors of the denominator. If the prime factors of denominators consist of 2 alone, if, okay, in the prime factorization of q, if you have 2 alone, okay, yes, that is a terminating decimal. If you have 5 alone, only 5 you have, it's like 5 power 3, 5 power 4, yes, that is also a terminating decimal. And if you have 2 and 5 both, yes, that is also terminating decimal. If the prime factorization of q has 2, 5 and one more prime factor which is 3, then it is not a terminating decimal. You should have only 2 or only 5 or both 2 and 5. But apart from this, you should not have any prime factor at all. Okay? If it does not have, then it is terminating. If you have any, like see here, 5 into 3 is there. 5 is there. So don't get confused, sir. 5 is there, so we can write it as terminating. No. You should have 2 also and only 2 and 5. You should not have any other prime factor. But in this case, 3. Definitely it is a non-terminating decimal. Okay, remember this carefully. You should have 2 alone or 5 alone or 2 and 5 both. Only these 3 cases are allowed. If you have other than this, any other prime factors if you have, definitely you can conclude that it is a non-terminating decimal. Guys, you can check by division. You can verify this by division also. Okay, you will get the same answer. I hope you understood this clearly. Okay, let me do next topic or next sum. Check whether the following are rational or irrational. It means we have to check the given numbers are rational numbers or irrational numbers. Okay, I hope I can remove this because you guys know how to like write the working, because this working also very important for each and every sum. Because I did only for this sum, you have to write the same working for all the sums. Okay, yeah, check whether the following are rational or irrational. Okay, first one, what is the first sum? It is given 43.123456789. Okay, so how can we say whether it is a rational number or irrational number? As I told you in the previous classes and the videos also, I discussed this. Any decimal expansion which is terminating, that can be considered as a rational number. See, two cases are there. One is a number, a decimal expansion is terminating. Any decimal expansion is terminating. One case. Next, terminating and non-terminating and repeating. Okay, non-terminating and repeating. These two cases, we can say they are rational numbers. Okay, when it is terminating, one case, or some cases you will get non-terminating and repeating. When you get these two cases, then we can say that this is a rational number. And when it is a irrational number, non-terminating, it should be non-terminating and also non-repeating. It should not repeat. Okay, any digit in this expansion should not be repeated, then it is irrational number. Okay, carefully understand this. You have to know this properly, then only we can do this one. So basically what I am telling is any decimal expansion which is terminating or non-terminating and repeating, then we can consider that as a rational number. It means if any, you see, this is a terminating decimal. Where is that? That is a terminating decimal. That we can say that it is a rational number. But we don't know whether it is this. We know this is a non-terminating decimal. Whether it is repeating or non-repeating, we have to check the decimal expansion. Basically, what I am telling, if any rational number, a decimal expansion is terminating, that is considered as rational number, and if it is non-terminating and repeating also, it is considered as rational number. When it is an irrational number, if the decimal expansion is non-terminating and non-repeating, that is considered as a irrational number. Especially, we have a very good example. Root 2 is there. Root 2 is 1.414235 or something like this. You will keep on getting it. It will never stop. So this is what kind of number? This is a non-terminating. Why? Because it is not, division is not getting stopped. So definitely you will get decimals more and more. Correct? It will never stop. So that is why it is non-terminating. And repeating, is it repeating? See, nothing, no number is exactly repeated. 4, again 1 you got, again 4 you got, again 2 you got, 3, 4. There is no order. Nothing is repeating over there. So that is why this is considered as an irrational number. So now we will come to the sum. So what is this first sum? 43.123456789. In these you see, here it is stopped. It means terminated. Easily we can see that the given decimal form or decimal expansion is terminating. Correct? It is a terminating decimal because it is stopped. Division is stopped. It is, they didn't put dot, remember that. Okay? So this is a terminating decimal expansion. Hence, it is a rational number. That is only they ask you to find out. So because it is having a terminating decimal expansion, so we can say that this is a rational number. So what basically you have to see whether it is a terminating decimal expansion or not. Yes, it is a terminating decimal expansion. So you can conclude this as a rational number. Okay, that's all. Next one we will see. Okay, this is not a difficult sum. These sums are very easy. you should know the technique, or you should know the rule. Okay, what kind of decimals is it? Like, rational number, what kind of, decimal is irrational. Second one is 0.1201201200, correct? 1200, 1200, So, and some people will get confused, sir, 12 is repeated every day. It is not like that. Okay. See, 120 is there. Again, 120 only repeated, then it is a rational number. Okay. In this case, if you observe 120, 0.120 is there. Next code is there. 1200 is there. Correct. Next, 3 zeros is there. You can take 3 zeros here. 3 zeros is there. Next, we have 4 zeros. So here you consider nothing is repeated. Correct? And it is a non-terminating decimal. So here the decimal expansion is non-terminating and also non-repeating, correct? And also non-repeating. It is not nothing, no number is repeated properly. Repeating in the sense, it is not like 1, 2, again 1, 2 here, not like that. 1, 2, 0 means 1, 2, 0 only should come another as a sequence. Again 1, 2, 0. That is considered as repeated. The same should be repeated. Okay, it is not repeating like that. So that's the reason it is considered as non-terminating and non-repeating decimal. So hence we can say that hence it is a what kind of decimal number? Irrational number like pi root 2. Okay, we have pi root 2 and root 3, root 5. Those are irrational. This is also one kind of irrational. One irrational because the main reason is you should understand it is not repeating and non-terminating. That's the reason it is a irrational number. I hope you understood this. Okay, I'm going to explain once again for this. It is very easy. Just have to find out the type of decimal expansion. The last one is 43.12345678. So this sum you see here, and in last in 9th standard you also study there's a concept called recurring numbers. Recurring in the sense of repeating. For example, if I write 0.231, we call it as hyphen. If I put hyphen like this, what is it mean by this? It means 0.23333. Okay, which is not stopping. It's recurring. Recurring means 3 will be repeated. How many times? Infinity times. If you do division, you have to divide. It will never end. Trillion times it will come. More than that also it will come. So 2.0.2333 dot dot. So this 3 bar, instead of writing 3333 dot dot, we are writing 3 hyphen. 3 bar. It means it is a recurring decimal. Which is recurring? Only 3 is recurring. Okay, if I put like this 23 for 2 3, okay, it is like this 0.232323. Okay, you have to put that hyphen only for the recurring, which number is repeating. For that number you have to put that hyphen. So in this case it is 0.232. So as we discussed, any decimal is non-terminating and repeating also considered as a rational number. So third one, if you see here, they put 43 point, what is that, 1, 2, 3, 4, 5, 6, 7, 8, 9 whole bar. It means what? This is also written as, this can also be written as 1, 2, 3, 4, 5, 6, 7, 8, 9. Again 1, 2, 3, 4, 5, 6, 7, 8, 9 dot dot. It means same number will repeat again. Again, if you divide, again you will get 1, 2, 3, 4, 5, 6, 9. Like that, it keep on continuing. So this comes under, okay, non-terminating and repeating. Here, the decimal expansion is, you have to write the steps properly, okay, is non-terminating and repeating. Remember, non-terminating and repeating. Hence, it is a It is an rational number, correct? As we discussed, if the decimal expansion is non-terminating and repeating, then also it is considered as a rational number. So this is considered as a rational number. I hope you understood. Okay, this are also maybe they can ask for 1 mark, or in multiple choice questions you might expect this kind of like sums. Okay, I hope you understood this class, and I hope I made you understood the concepts clearly. So thank you very much, and please like, comment, share and subscribe to our channel and support us. Have a great day for you. Thank you.